Hey, hi, welcome to all about engineering YouTube channel. So today we are going to see the numericals on introductory part of control system. So in last lecture, what we have seen in last video, we have seen that open loop control system, closed loop control system, and also singularities function for control systems. Okay. So actually in last lecture I have elaborated all the derivation for these two control system. If anyone want to revise that one, then he can refer introductory part of control system. So in today's class, what we are going to do in today's class, we are going to solve the numericals on control system part. Okay, on introductory part. So first we'll move towards numerical. Okay, right one. So this is one of interesting numerical on the control system introductory part. So first I will elaborate the meaning or what they want. First I will elaborate that one, then I will describe each and every step of our answer. Okay, right? So first we'll read the impulse response of system is c of t is equal to minus t e to the power minus t plus 2 e to the power minus t. Okay, this is an important condition for t greater than 0. Its open loop transfer function will be. So what they want open loop transfer function. Okay, and what they have done, actually there is one system. Okay, whatever there may be, either it is a open loop or closed loop. In this case it is a closed loop system. Okay, total closed loop system. And what they are doing, they are providing impulse input for this system, and output of this system is given over here, and output is given in t plane. Okay, time domain, this t time domain. Okay, so it is represented by c of t, right? So this is your output and impulse. Okay, r of s is nothing but your impulse response. In last class we have covered this impulse response. Okay, means it is only present for t is equal to 0, rather than t is equal to 0 it is a infinite, or it is 0, right? So they want a open loop system and they provided impulse response. So what we have to do, then now we'll move towards our analysis part, right? As respect to analysis part. Okay, right? So now actually in the question they have described that c of t is equal to minus t to the power minus t, like this. Okay, so now what we are going to do, for that t time domain we are going to apply a Laplace transform. So Laplace for transform for the given t time domain equation is like this: c of s is equal to minus 1 divided by s plus 1 square, right? Because e to the power minus, for example, e to the power minus 80, this is t time domain function. So for this Laplace transform will be 1 by s plus 1, right? 1 by s plus a in this case. If it is 1, then we have to write 1 over here, right? So now what I am going to do, we are taking LCM for this 2 in function. So for this LCM is a s plus 1 bracket square, and we are cross multiplying these two while taking LCM, right? So this is nothing but your final transfer function. And you have to remember that in decoding of your question I mentioned that this is given as a closed loop transfer function. So how I can know? Because what they have mentioned, they have provided impulse response to total system, and they asked about a open loop system, right? So for this open loop system they have asked. So now this answer came for a closed loop system. So now we have to convert this closed loop system into open loop system. So in last class I have described about the closed loop system formula, that is nothing but this g of s divided by 1 plus g of s h of s. So I am equating this total formula with respect to this total term, right? So now what I am going to do, I am cross multiplying these two, means s plus 1 square is multiplied with g of s, and 1 plus g of s h of s is multiplied with 2s plus 1. So after cross multiplication, okay, right, so after cross multiplication, what I am going to do, I am transferring this 2s plus 1 g of s to left hand side, right, and I am taking out this g of s as a common over here, and I am transferring all the part towards my right hand side, right, understood. So this is nothing but your final open loop transfer function, this one, 2s plus 1 divided by s square. So this is a theoretical way. Actually, for different examples, if you don't know short form to how to transfer a closed loop transfer function to open loop transfer function, then definitely you have to follow this route. But for preparation of a gate or ESE, in gate anyhow you will get 3 minutes, approximately 3 minutes for each question, and for 1 mark question it is approximately 1.5 minutes, okay, right. But for ESE preparation, definitely you have to use this short trick for this one. So here I have provided this short method, okay. So what you have to do, if you want to transfer open loop transfer function to closed loop transfer function, then definitely what this is short trick will apply for at that part, okay. So what you have to do, you have to put numerator as it is, and denominator you have to subtract denominator with the help of a numerator minus numerator, then remaining transfer function will be your required transfer function, that is nothing but your open loop transfer function. So actually I have applied this short trick. If you want to try, you can pause this video and you can try that one also. So, okay, so definitely it is going to come like this only, 2s plus 1 divided by s square, okay, right. So now we'll move towards next example. Actually it is a somewhat interesting, right, so we'll move towards that one. So this is the next example, right. So first I will decode the question, then we'll move towards the answer, right. So I will read the question for you. So what is a open loop DC gain? Okay, so write this open loop. They want open loop system should be open loop. Then next target is, for that you have to gain a DC gain, okay, you have to obtain a DC gain for that open loop transfer function. And system is like it is a unity feedback system having closed loop transfer function. I mean, this closed loop transfer function means this system have a negative unity gain feedback, means f of s is equal to 1, okay. And your summing point negative feedback means this is supposedly this is r of s is as a input, okay. Then at this point you are getting this one is a h of s, right, this is h of s, and you are getting negative feedback, this minus, right, and this one is a plus. So this one means negative feedback, and negative in first lecture I told that negative feedback is much more stable as respect to your positive feedback, okay. That is a theoretical part. So now we'll move towards the particular answer. So for answer, first what I have to do, first target is I have to obtain open loop transfer function. So in previous example I told that one short trick method or one theoretical method. So I'm going to apply that one. You can apply any one, okay. Either you want to go for long method or short trick, that is your choice. So here actually I have applied short trick method, okay. So this is nothing but your closed loop transfer function, okay. I wrote it as like as it is. Then I am subtracting minus s, means I am subtracting numerator from denominator part, okay. So that will be minus s and minus 4, right. So I am subtracting that one, okay. So s plus 4 divided by s square, and this 7s minus 1s means 6s, okay, right, and 13 minus 4, so it will be plus 9, right. So first target, actually we achieved first target. So next target is they want DC gain. So DC gain means what? It means that your frequency of system, means you are giving input such like that a signal have zero frequency, okay. It means like that, zero frequency, okay. So what you have to do, actually if you know the some basic term, then it is like yes, what we are replacing yes with respect to j omega, okay. So omega means what? J into 2 pi f, right? J into 2 pi and f. Okay, so if I am putting s as equal to 0, means suppose I am just now I told that DC gain means you have to feed a signal who have 0 frequency. So if I am putting f as a 0, then this total omega will get will be replaced as 0. So if omega is 0, then total s should be 0. So that only I am here doing, because the limit s tends to 0. Understood what I want to say for DC gain? Okay, right. So now I want first target already we have achieved, so I will take just I will clear this one just second. Okay, so right, so what now I am going to do, just I am replacing with this, I am applying this DC gain condition over my open loop transfer function. So now I have to put a 0, so I will cross with this blue mark. Okay, so that will understand this is a 0, this will be 0, and this yes is 0. So remaining terms are your 4 and your 9. So it will be 4 divided up by 9 is your respective answer. So you have to click, you have to choose that option. So right, understood. Means from this example, for previous example, what you have understood, for previous example you understood that how to convert closed loop system to open loop system, right? This is your understanding. Okay, closed loop to open loop. In this example, what you have understood, this also is closed loop to open loop, and also DC gain concept. DC gain actually while solving numerical, what you have to understand, you have to understand that what is the meaning of that numerical and what they want from our side. So that is a basic understanding they require, right? So now we'll move towards the second numerical part, that is also somewhat more interesting, like this only. So we'll move towards this. So in this lecture, actually what I have done, I am taking such numericals means so that you can understand at least one concept from them. Okay? Otherwise means you can try different kinds of numerical, right? Also, so now we'll move towards the next numerical. So first I will decode this numerical. So it means that what is the impulse response of a system shown in a figure. Okay, so what they want, actually this is a impulse this is a impulse input. Okay, R of S is a 1 is equal to 1, that is the impulse, and this is your open loop system, because you are able to see that in this block diagram. Next class I will take this block diagram and signal flow analysis or signal flow representation. So okay, just for sake of purpose, just understand this is a block diagram. This is a block diagram representation for your control loop system. So this is open control loop system, and this is your output. So what they want, this word is much more important. So what is the impulse response of a system? This is question is much more straightforward. So what they want, actually they want to ask that suppose I am providing impulse response for any system. In this case it is 1 by s into 1 by s plus 1. So what is the output for this input? Okay, so we'll try to decode it. So if I want a transfer function, in first class only I told the transfer function is nothing but a Laplace transform of output divided by Laplace transform of input at initial condition, means all initial conditions should be 0. So I am doing that only. Transfer function is a C of s divided by R of s. So C of s divided by R of s is nothing but 1 divided by s into s plus 1, right? So actually yes, this is much more understanding. So all options, if you are able to see that this all options are given in t domain. Okay, and what we are doing, our transfer function is given in s domain, right? So all this transfer function is given in s domain, but all options are given in a t domain. So what we have to do, it is better to convert this s domain to t domain. So first what we'll do, we'll elaborate this transfer function, and finally we are going to convert this s to t domains. Okay, right? So this only. So now what you are going to you are going to apply Laplace inverse transfer function for this transfer function. So here it is. So this means like that what you are doing, a divided by s, right, plus b divided by s plus 1, right? Like that only you are going to replace this equation, is equal to 1. So you are taking LCM for this side, so it will be a into s plus 1 like this, right? S plus 1 plus b into s, okay, is equal to 1, and you are putting s is equal to 0, you are putting s minus 1 in this equation, right? In this equation, okay. So finally you are came to know that a is equal to 1 and your b is equal to 1, and in this equation b is equal to minus 1. So in this equation you are going to replace that one, okay, right? So finally now you have to take a Laplace inverse transform of this equation, okay. So Laplace transform for 1 by s is nothing but 1, okay. That formula, t to the power n formula, that is n factorial divided by s plus 1, okay. So if you are applying inverse Laplace transform 1 by s, then it will be 1, and this is the magnitude 1 into e to the power minus 1, because what just in at the starting I told that e to the power minus at is replaced by 1 divided by s plus 1, like this, right? So like that you have to replace this transfer function. If it is a s plus at, then it will be s minus 1, right? So it is somewhat much more simple. So what is the understanding from this example? That is important. So understand is like that if they are providing into a t domain, then you have to transfer at t domain, and like this only. So now we'll move towards the next example. So now we'll move towards this example, right? Actually it is somewhat much more means from this example you are able to get different points, so it is somewhat important, as it is all other whatever I explained that are important, but this is much more important than these above three examples, right? So first we'll decode what they want, okay. So the impulse response of a system having a transfer function, so they have provided a transfer function, okay. And impulse means input is impulse, this is first understanding. Second one, they have provided a transfer function as shown in a figure, and third one, they have provided a figure. So what you have to see over here, okay, this is a t, okay, this diagram is in a t domain, right? This is a important understanding, and all options are given in a t domain, right? So we'll move towards answer. So first what you have to do, first this is the impulse response, okay. So impulse response, impulse singularity function property is that whatever you are going to feed, that is your only transfer function. So now I'm going to consider this transfer function, which is already provided in a numerical. So if I am taking a Laplace transform for this equation, then it will be, this is a magnitude part, and 1 divided by s plus alpha is in nothing but e to the power minus alpha t, right? So this only. So now what you have to do, now you have to use this diagram. So if you are going to put, means first time at t is equal to t2 at this point, okay, you're able to see that's t2. Then what is magnitude for this transfer function, that will be 0.337 k. So I am writing that only, and I am putting this value, because if I am putting t is equal at this, I am replacing this t by t2, then this transfer function definitely, or this output definitely have to show this value only, okay, because in impulse response singularity function, your output is nothing but your transfer function, right? So that only I am equating over here, this is only, and I am finding out the value, right? So after simplification of this equation, total equation, right? Just a second, I will show. Yes, after simplification of this one, finally you are came to know that alpha is equal to 1 by t2, right? So now you are able to see that what they have asked, they ask like this, okay, what is the value of alpha? So, and in answer you are able to see the alpha is equal to 1 divided by t2. So this is your respective answer, right? So this is some numericals on introductory part of open loop transfer function or closed loop transfer function. So after that you have to solve different previous examination numericals. Okay, right. So if you are facing any problem over there, then kindly reach to our YouTube channel. You can comment that numerical, or you can mail also. So thank you for watching and your patience. Okay, so take care. Bye.